The amber bracelet you once wore may be trapping a creature that struggled in despair. 125 million years ago, scientists found that many insects in amber did not die peacefully. They are frozen in violent poses, sealed while still alive. They watch the golden liquid rise. No air. No escape, then eternal darkness, for over 100 million years. And the cause was not disaster, but a beetle under 2 millimeters long, tiny, lethal, still alive today, possibly hiding inside your home. But to understand this 54 million year attack, we must ask one question: amber, what is it, really, not tree tears? Amber is actually a tree's bandage. When a tree is bitten by insects, invaded by fungi, or its bark is torn open, it releases a thick, golden liquid. This is resin, thicker than sap. It seals wounds, kills bacteria, and sometimes crushes the intruder on the spot. But not every tree can do this. Only conifers, ancient gymnosperms, produce resin, and 125 million years ago, during the Cretaceous, they ruled the earth. The first condition was in place. But resin alone is still not enough. To become amber, left exposed to open air, it will dry and crack, burn away, or decay completely. To transform into amber, resin must be buried deep, sealed away from oxygen, then subjected to intense pressure and heat for millions of years. 3 conditions must occur at the same time: a tree capable of producing resin, a wound severe enough to make the tree bleed, and that resin must be buried quickly before it is destroyed. The probability of all this happening together is incredibly small, but during the Cretaceous period, the impossible did happen on a global scale. Scientists call this era the Cretaceous resin explosion. It began 125 million years ago, and lasted continuously, for 54 million years. During that time, the earth appeared to be coated in a layer of glowing golden liquid. From Lebanon to Myanmar, from Spain to Canada, amber deposits rose everywhere. In Lebanon alone, less than 10 kilograms of amber revealed over 8,000 ancient organisms. What does that tell us? It means that in that era, nearly every tree was bleeding violently. So what wounded the world's forests? All at once. At first, scientists blamed the climate. The Cretaceous was one of the hottest periods in Earth's history. CO2 levels were far higher than today. Oxygen levels were elevated as well. Heat meant stronger storms, tearing branches and bark. High oxygen meant frequent wildfires. After each fire, surviving trees released resin to seal their wounds. It sounded logical, but there was a fatal flaw. If climate were the only cause, amber would be evenly distributed worldwide. It wasn't. Deposits clustered mainly in the northern hemisphere, forming strange, uneven patches, which meant one thing: climate was not the only culprit. There was another: local, mobile, contagious, and it was alive. At first, paleontologists narrowed their suspects to bark beetles. You may recognize their modern relatives: wood-boring beetles, the nightmare of today's forests. A single beetle drilling into a pine can, within months, leave an entire forest dead. And in the Cretaceous, their ancestors already existed. Even more frightening, some species in this group evolved a survival strategy that was truly horrific. They are known as fungus-eating beetles. They do not feed on wood. Instead, they farm fungi inside living trees. Yes, they are farmers. They drill tunnels into the trunk, seed fungal spores along the walls, wait for the fungus to grow, then harvest it. To feed themselves and their larvae, to protect their farms, they remove rival fungi, like pulling weeds. Before moving to a new tree, they store spores inside a special pouch in their bodies, the fungal pouch. This pouch keeps heat and humidity stable, allowing the spores to survive the journey. At a new tree, they release the spores and begin the cycle again. The system is nearly perfect, but for trees, it is a disaster. The fungi they carry are deadly enemies. Once infected, the fungus spreads through the trunk, halts growth, and eventually kills the tree. The tree's only defense is to release massive amounts of resin, trying to trap both beetle and fungus. For years, scientists believed these farmer beetles caused the 54 million year resin explosion. The case seemed closed. Then, about 10 years ago, everything changed. When scientists re-examined Cretaceous amber, they found an awkward truth: fungus farming beetles are almost absent from amber of this age. If they were the killers, why weren't they trapped at the crime scene? More importantly, the fungal pouch itself evolved 54 million years later, long after the resin explosion had ended, which means that in the Cretaceous, fungus-eating beetles didn't yet know how to farm fungi. They were innocent. So who was the real culprit? The answer came from another beetle, ignored for decades, the wood-boring beetle. The name sounds unfamiliar, yet in the age of sailing, seamen discovered their ships were often riddled with holes by it. Even solid warships could rot from the inside within just a few years. But long before that, in the age of dinosaurs, these beetles were already drilling into forest trees. At first, they seemed harmless. They bored into wood to lay eggs, larvae hatched, fed on wood, and the adults eventually flew away. Nothing too dangerous, or so it seemed. But one crucial detail was missed. When the female lays eggs, she leaves more than eggs behind. She also deposits fungal spores, stored in a special groove within her abdomen. A 2025 study by the Max Planck Institute revealed the fungus's true horror. It releases large amounts of acetic acid, strongly acidifying its surroundings. Almost all other fungi die, only this one survives. When the larvae hatch, they do not eat wood, they feed on the fungus their mother cultivated for them. She built a farm in advance. And in Cretaceous amber, wood-boring beetle fossils appear in overwhelming numbers. They were the species that truly exploded in that era. The truth finally came to light. Paleontologists had found the right weapon, fungi, but accused the wrong killer. The disaster was not caused by fungus-farming beetles, but by wood-boring beetles. They turned their own bodies into vehicles for a biological weapon, carrying lethal fungi from one tree to the next, from one forest to another. As trees began to die, their only option was a last, desperate defense. They released vast amounts of resin, trying to seal both beetle and fungus. In a battle they could not win. That flowing resin trapped countless unlucky lives, insects, lizards, even dinosaur feathers and tails. Buried alive, they slowly transformed into amber. In 2016, Chinese paleontologist Xing Lida discovered a dinosaur tail preserved in Myanmar amber, only 6 centimeters long, covered in soft, delicate feathers. It looked as if the animal had just died. The specimen was named Eva. Synchrotron X-ray analysis revealed exceptionally high levels of ferrous iron, a signature of hemoglobin. This meant the blood inside the tail had not yet fully dried. When the resin enclosed it, the dinosaur was swallowed by resin immediately after death, or possibly while still alive. And the revelations continued. In 2023, scientists in Spain discovered a dinosaur feather in amber. With beetle larvae feeding on it, they consumed skin debris and parasites, cleaning the feathers. The oldest known symbiotic relationship between insects and dinosaurs. Amber is a time machine, freezing a world from 100 million years ago. And it is not the product of chance, but the result of an ecological catastrophe, engineered by beetles and fungi together. Now return to the original question. When you look at a piece of amber, you are not just seeing jewelry. You are witnessing the remains of a 54 million year ecological war. Each piece of amber is a scar on a tree, each trapped creature, a victim. And the tiny culprit may still be hiding today, beneath a ship's hull, or inside the beams of an old house, boring into wood, sowing spores, and moving on, just as its ancestors have done, for 125 million years.